Alright, so 30 could be a long problem. I'll try to do it as quickly as possible because parts B and C are both cross products. And if I do it out completely, then it might take a while. But let's just do it. So we got mass equals 2 kilograms. Distance or displacement vector is 2I plus 4j minus 3k meters. Velocity is negative 6I plus 3j plus 3k meters per second, and the force they give us is 6I minus 8j plus 4k newtons. Part A is just asking for the acceleration, so that's pretty straightforward. Newton's second law, F equals ma. We're looking for, so divide both sides by m. So A equals F over m. So just divide all of these by 2, because the mass is 2. So this becomes 3I minus 4j plus 2k. So that was easy. And that's meters per second squared. Part B, we're going to use angular momentum is m times r cross v. So we're going to do a cross product of r, which is our displacement vector, d, and v here. Alright. So, how can I do this quickly? Well, I'm just going to do it out. So I'm going to skip the I cross I, j cross j, k cross k terms. We already know those cancel. So I'm just going to do I cross, like I cross k, j cross I, j cross k, 3 cross k cross I, k cross j. Ready? So it's going to be, and I'm just going to multiply before. So 2 times 3 is 6. I cross j, so that's right, up, that's positive k. 2 times 3 is also 6. And I cross k, so to the right, towards you, that's down, so negative j. And then 4 times 6 is 24. J cross I, so up to the left is towards you, so positive k. 4 times 3 is 12. Up and towards is to the right, so positive I. And then 3 times 6 is 18. There's 18. Negative k is away. Negative I is to the left, so that's up. That's positive j. And then 3 times 3 is 9. Negative k away. Positive j up. That's to the right, so I. Alright, let's combine them. So L, the I terms, plus 12 plus 9 is, we gotta multiply by 2 later. Plus 2 plus 9, that's, 12, and 9 is 21. The j is negative 6, positive 18, so that's plus 12. And then the k's, we got plus 6, plus 24, so that's plus 30k. And then let's multiply by 2, so that becomes 42i plus 12, 24j plus 60k. And the unit for that is kilogram meter square per second. Alright, cool, that wasn't too bad. Now let's do part C, which is torque. Torque is R cross F. And I'm going to do the same thing. I'm just going to skip the the I cross I, the J cross J, K, K, K. So, okay, so let's do 2. This is R cross S, so 2 times 8 is 16, so 16. To the right, down is away from you, so that's negative K. 2 times 4 is 8. Up, no sorry, to the right and towards is down, so that's negative J plus. Alright, 4 times 6 is 24. Up to the right is away, so negative K. Okay, 4 times 4 is 16. 4 times 4 is 16, so up towards is to the right, so positive I. Now, 3 times 6 is 18. Away and to the right is down, so negative J. 3 times 8 is 24. Away, down is to the left, so that's negative I. And so the torque, let's combine the I terms. We get 16 minus 24. That's negative 8. J terms, negative 8. Negative 18 is negative 26. K terms, negative 16, negative 24. That's negative 34, negative 40. And the unit for torque, we could use a Newton meter. Alright, not too bad. Part D. Now, we never really truly used the dot product. Well, I guess you could have, but this part will show you the power of dot product when you're dealing with three-dimensional components, I, J, and K. First off, the general rule for dot product: A vector dot B vector equals the magnitude of A times the magnitude of B times the cosine of the angle between them, and perpendicular, cosine of 90 is 0, so anything perpendicular is 0, so only the parallel terms when you multiply the components out, when you distribute the components, remain. So only AX, BX remain, and only AY, BY remain, and only AZ, BZ remain. Alright? So we're going to use this. We know everything except theta. And we are doing the angle between, what was it? This is number 30. Velocity and force, so the angle between these two. So A is actually V dot F. So first off, what is the magnitude of V? Well, you can do Pythagorean theorem. V is the square root of negative 6 squared plus 3 squared plus 3 squared, and that equals 7.35 meters per second. The force magnitude is the square root of 6 squared plus negative 8 squared plus 4 squared. And that's 10.77 newtons. So this becomes 7.35 times 10.77 times cosine of the angle. And that's going to be the two x components multiplied, so that's going to be negative 6 times 6 is negative 36. And then 8 times negative 3 is negative 24. 3 times 4 is 12. And just to save some time, I'm not going to do the algebra. You could do that out. Solve for the angle, and theta equals 127.3 degrees. So that's a very powerful use. Does that make any sense? That shows the power of the dot product when dealing with three-dimensional vectors. This would have been easier to do without the dot product. With just a two-dimensional, you could just draw like your xy axis. You know, one of them goes like that, the other maybe goes like that, and figure out the angle between them. That's pretty easy. Just do triangles. But once you get that third dimension, it's not quite so easy to do that in your brain. So dot product takes care of it for you. Alright, talk to you later.